Hi everyone, this is Mrs. GA, and today we're going to talk about angle bisectors of triangles. So please recall that an angle bisector is a ray that divides an angle into two congruent parts. So remember, bisect means to cut in half exactly, so that's why we get two congruent parts. Also, something that's useful to know for today's lesson is that when I ask you to find the distance from a point to a line, we're always going to use the length of the perpendicular segment from the point to the line. So we're always going to draw a perpendicular segment to get there. So it's really the fastest way to get from a point to a line. Okay, so now let's talk about the angle bisector theorem. The angle bisector theorem states that if a point is on the bisector of an angle, then it is equidistant from the sides of that angle. So look at this picture. I see that ray PC is our angle bisector. I know that because I see that there are two congruent parts made from ray PC. So I know that C is on my angle bisector. That means that point C is equidistant to the sides of my angle. So that means that CA, segment CA, is congruent to segment CB. So then I can make this statement. So again, if a point is on an angle bisector, then it is equidistant to the sides of the angle. Now the converse of that states that if a point is equidistant from the sides of an angle, then it must be on an angle bisector. So remember, for a converse, we switch the if-then. So in this case, if we know that CA is on CB, well, then we know that angle APC is congruent to angle BPC. Essentially, we know that PC, ray PC, is an angle bisector. So again, just to compare, this one says if it's on an angle bisector, then it is equidistant. The converse says if it is equidistant, then it must be on an angle bisector. So let's see if we can use these two theorems to help us solve examples 1 and 2. So here they would like us to find the length of LM. So here I notice I can see from the picture that KM, ray KM, is an angle bisector. So using the angle bisector theorem, I know that any point on my bisector is equidistant to the sides. So I know that JM is congruent to ML. And if that statement is true, then LM must be equal to 14.2 units. Okay, let's look at example 2. So here this says angle ABC is 114 degrees. So that's my large angle. Find the measure of angle ABD. So right now I can see that AD is congruent to DC. So using the converse of the angle bisector theorem, we can state that these two angles must be true. So since this point is equidistant to the sides of my angle, I know that this must be an angle bisector. BD, ray BD, must be an angle bisector, which means that those two angles are congruent. ABD is congruent to CBD. Angle ABD is congruent to angle CBD. Well, if the two angles are congruent, they have the same measure. So we can essentially take our larger angle, which is 114, cut it in half to create two equal segments, and what we get is 57 degrees. So that is the measure of angle ABD. All right, so now we're going to learn about what happens when we have a triangle with angle bisectors. So now we're going to learn about a new term. This is called the incenter. The incenter is the point of concurrency of your three angle bisectors. So remember, point of concurrency is where three or more lines intersect at a single point. So here you can see that we have three angle bisectors within this triangle. I see that I have two congruent angles here, here, and here. So these are my angle bisectors. And you can see that they are intersecting at point P. So in this case, point P is our incenter. So the incenter theorem tells us that the angle bisectors of a triangle intersect at a point, which in this case is our incenter, point P, that is equidistant from the sides of a triangle. So we know that the incenter is equidistant from the sides. And remember, that's always going to be that perpendicular distance. So we know that PZ is equal to PY, which is also equal to PX. And again, we can state this because we know that point P is the incenter, where our three angle bisectors are intersecting. So let's look at example 3. Here they say that QX and RX are angle bisectors of triangle PQR. So that must mean that point X is our incenter. Here they ask us to find the measure of the distance from X to line segment PQ. So I'm going to draw in what they're asking us to find. They're asking us to find the distance from here to here. And remember, it's always going to be a perpendicular distance. But we also know one more piece of information. We know that XY is 18.8 units. So according to the incenter theorem, we can make the statement that line segment XY is congruent to line segment X. Let's give this a letter. How about Z? Because again, that's the distance from the incenter to the sides of your triangle. So if we know that XY is 18.8, that must mean that XZ is also 18.8. And there you have it. All right, let's try this last problem together. Here, again, we're told that QX and RX are angle bisectors. So again, that makes X our incenter. Here, they would like us to find the measure of angle PQX. Here's what we know so far. We know that this entire angle is 54, and we know that this is 14. So if we know that RX is an angle bisector, that must mean that this is also 14 degrees because angle bisectors make two congruent angles. We're also told that QX is an angle bisector, so that means that both of these angles right here and right here will have the same angle. Let's call them both X degrees. So this also is a measure of X degrees. So now we can use the Triangle Sum Theorem, and we can add up all of our angles, and they should equal 180. So I'm going to do 54 plus 14 plus 14 plus x plus x. Plus 14 plus 14 plus x equals 180 degrees. From here, I'm going to combine like terms, so I'll combine my x terms, so 2x, and then I'll combine my numbers to get 82 equals 180. So 2x equals 98. So that means that x equals 49 degrees. So again, they would like us to find the measure of angle PQX, and that is one of the angles we just found. So angle PQX equals 49 degrees. All right, that is all for today's video. Thank you so much for watching.